Hi guys, alright, we're ready for math. Today we're looking at 8.2 extended facts. This is practicing explaining how basic multiplication and division facts help us solve larger and extended facts. You're going to be able to practice that on IXL and do a student math journal page where again you're going to want to show me your thinking on Flipgrid. In order for us to be able to do these things, I'm going to go ahead and model my thinking and share a little bit about what to do. And so this is part of our computation standard where we want to be able to show the relationship between multiplication and division. We want to have this basic demonstrating of fluency with multiplication with demonstration of corresponding division facts from 0 to 10, which really takes us up with a lot of different numbers that we're going to want to be able to learn. And so we're really focusing on these 10s today, because not all numbers are going to be basic facts of like 2 times 3. Sometimes they're larger. Like when I went on vacation last spring break last year, I went with friends and we had to get 2 different rooms, and each room cost $60. And so I might know 2 times 6, but I don't know 2 times 60. So today's lesson would help me be able to do this, solve this problem with solving multiplying facts with extended facts. And so what is an extended fact? Well, an extended fact is where you take the basic fact like 8 times 3, where it's just single digit numbers, and it equals 24, something I should already know. And then we're going to take that basic fact and extend it to times 10 or times 100 or times 1,000, things that end in 0, right? Because an extended fact is when you use a basic fact to help you solve a similar equation. Something times 10 times 100 times 1,000, you just add zeros to the end of your answer. So you take 8 times 3 equals 24. Well, if the problem is now 80 times 3, well, it's still 8 times 3 is 24, but there's 1 0 added, so you're going to add 1 0 to your answer. Same thing if you flipped it from instead of 80, it's 8 times, and instead of 3, it's 30. It's still 1 0, so you're going to add 1 0 to 24. But if you change that to times 100, and 100, there's 2 zeros here. So like 8 times 3, still a basic fact, which is 24, but there's 2 zeros added here, so I'm going to add 2 zeros here. Just like here, instead of it being 800, it becomes 300. Still, the other one only has 1 digit, so you're just adding those 2 zeros to your answer. Here in 1,000, same thing. 3 zeros in 1,000, 3 zeros here in 8,000, no zeros with the 3, so you add 8 times 3, which is 24, and you have those 3 zeros, right? That's an extended fact. So I'm going to model that here. If I see the problem 300 times 5, I'm going to have to find what is the basic fact. And so I'm going to look and see, well, here are the zeros, so I'm going to find the ones that aren't zeros. So 3 and 5 are the ones without zero. So my basic fact here is 3 times 5. And I know that 3 times 5 equals 15. 5, 10, 15. Counting by 5 3 times. So how many zeros are in this question? Well, there's 1, 2. So there are 2 zeros. So I need to make sure that my answer is going to have the same amount of zeros. So if I know 3 times 5 is 15, I know that's going to go here in my answer. 15. And then there's 2 zeros here, so I need to add 2 zeros to my answer. And since now there's 4 digits, I know that I need to add the comma here to make it 1,500. So does my answer have the same amount of zeros? There's 2 zeros in the problem. There's 2 zeros in my answer. So I'm going to answer yes. They do have the same amount. So I want to make sure that I'm asking myself these guiding questions. Find the basic fact, find how many zeros there are, and then put that into my answer. Use the basic fact answer and have the added zeros. So that's what this problem is going to ask you to do on page 255. This is what is asked of you to do on your student math journal page here on page 255. That's what the do is. And then because that is our extended facts. But there's also an extension page that you can do on page 256 that is a little bit more, and it looks a little bit like this. It tells you the problem like my model did, and it says the basic fact that you can use to help. So that's what I showed you in my model. How could I figure out the basic fact on my own? On page 255, it tells you the basic fact gives you a larger fact and an even larger fact as well. So this is kind of just bumping up your thinking. We can do number 1 together in our Google Meet today, and then you can try number 2 and number 3 on your own. These are practicing multiplication facts, extended facts. So now I'm going to show you what if this was extended to division problems. It's the same idea. Find the basic fact, like 24 divided by 3 equals 8, or 24 divided by 8 equals 3. Okay, but you're having to divide. So just like here, we were multiplying, you have to think down here, well, 24 divided by 3, right, take out the 0, 24 divided by 3, well, that equals 8. Because in your brain, you're thinking, well, 3 times what equals 24? Well, 3 times 8. So this is just one more step added of thinking about what's the opposite of division. Well, it's multiplication. And just like you had 1 0 in the problem, you have 1 0 in your answer. If you have 2 zeros in the problem, you have 2 zeros in the answer, just like you did with the multiplication extended facts. So I'm going to model that thinking for you. So the problem is 350 divided by 5 equals what? Well, again, I need to find my basic fact. So 35 divided by 5. So I have 1 0 here. So now I have to think, how am I going to figure out 35 divided by 5? Well, I know the opposite of division is multiplication. So I have to think 5 times what equals 350. But when I see this, I'm really going to think, what's 5 times what equals 35? Because that's my basic fact. And so I know if I count by 5s, 5, 10, 15, 20, 25, 30, 35. I just counted on my fingers and I found that was 7. So that means 5 times 7 is going to equal 350. Ooh, no, 5 times 7 is just 35. So since there's a 0 here in my answer, I have to make the 7 have a 0 in the problem. Okay, so here, there's again a 0 here. So my answer here still needs to be the same as down here, because 5 times what equals 350? Well, it would be 5 times 70. So I need to make sure, again, my answer has 1 0 and my problem has 1 0. Okay, they go together. And so that's why we have to really think about this division as multiplication and use that missing factor here as my answer. Okay, it's a little bit trickier. If you think of this with blocks, if you look here, here's 350, 300, 10, 20, 30, 40, 50, and then you're breaking that up into groups of 5, and then every one of these groups would have 7. 10, 20, 30, 40, 50, 60, 70. 10, 20, 30, 40, 50, 60, 70, 70, 70, and 70, because this would equally split up into 5 equal groups of 70. And so that's what you would practice down here if you decide to do the extension page on page 256. That's here on number 4, and there's a part A and a part B to that. And so on number 5 down here as well. And so we could look at number 5 together if you would like to kind of practice this, and then you could do number 4 on your own. And we could do this during Google Meet, or you can try it on your own. And then this, we just want to look back at evaluate. This is something that we've done before where we've tried to connect our multiplication with division. This is an evaluate question that you might see next week where it says 30 divided by 5. Well, again, you need to think to yourself, well, what is 30 divided by, what's the opposite of division? Well, it's multiplication. So you would think 5 times what equals 35, that equals 30. And so you would want to find that problem here in our work. So you would see right here, 5 times blank equals 30. But down here, opposite, instead of saying 5 times blank equals 30, well, it's the same thing as you flip-flop. Blank times 5 equals 30. Right? That would also help me. But division, the opposite of division isn't division, right? So I know that one wouldn't work. And I know that I'm not multiplying 30 times something. 30 is my answer here for my multiplication problem, so that's not going to help me. Oh, that's just flip-flopped here, so that's not going to help me. And then this is asking me to multiply the two numbers together, which, again, 30 is supposed to be my big number. So that's not going to help. So these two problems right here would be the ones. And I know when I think of 5 times what equals 30, 5, 10, 15, 20, 25, 30, when I count on my fingers by 5s, it equals 6. So I know that 30 divided by 5 would be 6. If you would like to get some more extra practice, you can do this on Top It with the multiplication Top It to 1,000. Here it's going to give you these larger facts that you can play. Now this is not on part of your lesson. The lesson has you practicing on IXL because this is exactly like what it has you doing with our page 255, where it gives you one fact and has you extend it, seeing those patterns with this increasing place values. But if you want even more practice, doing it on Top It on McGraw-Hill is another great way to do that, to get some extra practice. Again, remember to show me what you were thinking for set 1 on page 255 on Flipgrid. I look forward to watching your videos. Thanks, guys.